You know that feeling when you're completely lost in some massive digital world and you just stop and wonder, how in the world did they build all this? From the tiniest indie game to a huge open world epic, there's this secret language of math working behind the scenes. So today, we're going to pull back the curtain and see the magic that turns simple dots into these incredible interactive worlds.
Seriously, how do they do it? We see characters running and jumping around in a world that feels solid. We see light and shadows and physics that all seem, well, believable. So is it all just some kind of crazy programming magic? Well, yeah, but it's a very specific and honestly a surprisingly elegant kind of mathematical magic.
Okay, I know what you're thinking. That sounds super academic, maybe a little boring. But stick with me here, because I promise you, by the time we're done, that sentence is not only going to make perfect sense, you'll actually see how beautifully it describes every single game you've ever played. That's it. That's the secret. Every single thing you see on screen, every character's movement, every camera swoop, it all comes down to one fundamental job: telling the computer how to move a single point from here to there. And to do that, we need a language of movement. And that language, it's called transformation. This is the set of commands we use to tell objects what to do on screen. And in this whole language, there are really only three main words that you need to know, the words that build almost everything else.
These are the big three. You've got translation, which is, just moving stuff. Rotation, which is spinning it around. And scaling, which is just making it bigger or smaller. And that's it. With just these three simple actions, you can create a shocking amount of different movements.
So let's check out the simplest one: translation. To get a new point, P prime, you just take your original point P and you add the translation amount, T. It's really just simple addition. Move it 10 steps to the right and 5 steps up. Easy. But how do we package these commands so a computer can use them for everything? This is where it gets really slick. We use something called a matrix. You can just think of a matrix as a little grid of numbers that acts like a command, like a verb. You multiply a point's coordinates by a specific matrix, and bam, the computer rotates it. You use another matrix, and it scales it. It's a really clean and powerful system. But here's where we hit a snag. The simple addition we used for moving things around, it doesn't really play nice with the multiplication we use for rotating and scaling. It's like trying to speak two different languages in the same sentence. It gets messy. How can we tell an object to spin in place and fly across the screen, all in one smooth, unified command?
The answer is this absolutely genius mathematical trick called homogeneous coordinates. It's the secret sauce. All we do is add one extra number, just the number 1, to our 2D points coordinates. It seems so small, right? But this one little hack lets us rewrite our simple addition for translation as a matrix multiplication, just like the others. It's a total game changer that makes everything speak the same language.
And just look at this. Because of that clever little trick, all three of our basic actions, moving, spinning, and resizing, can now be written in the exact same 3x3 matrix format. Suddenly, they all fit together perfectly. This is basically the Rosetta Stone of computer graphics.
And since they're all matrices now, we can just smush them together. We can multiply a translation matrix by a rotation matrix, and then multiply that by a scaling matrix. And what we get is one single, powerful matrix that does all three things at once. This is called composition, and it's the secret to making really complex animations happen super efficiently.
Okay, here's a perfect example. Let's say you want to rotate a character around its own center, not the corner of the screen. You can't just use a single rotation command for that, but with composition, it's easy. Step 1. You use a matrix to move the character to the center of the world. Step 2. You apply the normal rotation matrix. Step 3. You use another matrix to move it right back where it started. 3 simple steps combine to create one complex, perfect rotation. And you want to know the best part? This entire beautiful system scales up perfectly into 3D. It just works. We just add a third dimension, a z-coordinate, and we use slightly bigger 4x4 matrices. But the core logic, translation, rotation, scaling, and combining them all, it stays exactly the same. This is the bedrock of every 3D game world you've ever walked through.
Okay,
So we have the language, we have the mathematical verbs to move, spin, and scale anything we want in a 3D space. But that's just the alphabet, right? Who's the architect that takes this language and actually writes the story of an entire universe with it?
Well, that architect is the game engine. This whole idea really took off back in the mid-90s with games like Doom, where they figured out how to cleanly separate the core technology, the engine, from the game's actual art, levels, and rules. This was a huge deal, because it meant other developers could license that engine and build totally new games right on top of it.
A modern game engine isn't really one program. It's more like a whole toolbox of powerful, connected systems. You've got the rendering engine, that's the artist that actually draws everything. You've got the physics engine, that's like the bouncer, deciding how things move and what happens when they smash into each other. And then you have all these other specialized systems for character animation, AI, sound, and the scripts that control the game's logic.
And these things are absolutely everywhere today. Unity is famous for making it easy to release your game on PCs, consoles, and phones all at once. CryEngine has always been known for pushing the limits of photorealistic graphics. And you've got engines like Amazon's Lumberyard, which is built from the ground up to integrate with cloud services for massive online games.
But here's the kicker. Here's where it all clicks together. Every single one of those systems inside the engine, from the graphics to the physics to the AI, is built on the exact same idea, applying those matrix transformations we just talked about over and over and over, thousands of times every second.
Just think about it. The rendering engine is using transformations to figure out where every single object is from the camera's point of view before it draws them. The physics engine uses them to calculate an object's new position after gravity pulls on it. And the animation system? It's just applying rotation transformations to the bones in a character's virtual skeleton to make them walk and run.
And what's really cool is that sometimes, just by applying these simple math rules, you get these amazing, unexpected results. They call it emergent behavior. The developers of Team Fortress Classic never actually coded a rocket jump. They just made rules for explosions and rules for how players move. But players discovered that if you timed it just right, you could use the blast to launch yourself across the map, creating a legendary move the designers never even planned.
So let's circle all the way back to that crazy definition from the beginning: a soft, real-time, interactive, agent-based computer simulation. Well, it's a world built from simple math. That's our transformations. It's managed by an engine that applies those rules in real time, and it's filled with agents. That's you, the bad guys, everything, all interacting inside that simulation. See? It makes perfect sense now. The big secret is that the core ideas are actually pretty simple. But from those simple ideas, you can build infinite complexity, infinite creativity. From a single moving point to an entire galaxy, it's all built on this elegant language of movement. And once you know the blueprint, it really makes you wonder what new worlds are out there just waiting